Now we discuss the indexing and multivates, which is a unit 5. So this is my handwritten notes, which is easy for the understanding the indexing and multivates. So what is the indexing? So indexing is nothing but the data which is stored in the form of record in the database. For recognition, every record has its key field. What is meant by key? Whatever key which is nothing but a short note which is giving a description of regarding with that typical topic. For example, if you want to store the all record of regarding with the student, then simply we analyze the roll number, which is a key of that student. Then you just getting a whole information regarding with that student. So this is nothing but the key. So indexing is a database system in just like what you see in a book. For example, you considering as a single book. In that book, if whatever you want to find out, that which is find out with the help of that indexing. So the indexing is a data structure technique to retrieve the records from the database file efficiently. So when the database is very huge, then what is the exact need of that index? When the database is very used, then smallest transaction of that data is also take the more time to perform the actions. So when records are stored in primary memory, then it is easy to access it. So that's why the key is a very important part and index is also important part. So, but as we know, number of records may be a huge and we have to store in the secondary memory, that is the hard disk. Here we cannot store records like tables. So they are stored in the form of files, and that's why that files are stored into the different data blocks. So how we can access that data blocks? So each table will have a unique column or which is called as a primary key. So columns which uniquely determines each record in the table. Most of the time we use this primary to as an create an index. So this is the important of that index. So there are some techniques regarding with that indexing. So these are the different techniques. So first one is cylinder surface technique. Second one is hash indexes. Third one is tree indexes, and the fourth one is trie indexes. So what is the first one? Cylinder surface technique. It is a technique which is simplest of index organization, which is useful only for the primary key index. So it assumes that the records are stored sequentially in increasing order of primary key. The index consists of a cylinder index and several surface indexes. If the file requires C cylinders for storage, then cylinder index contains the C entries. And the associated with each of the cylinder is a surface index. Then if the disk has S usable surfaces, then each surface index has an S entry. Simply, what is C? C is nothing but the associated with the each and every cylinder, whatever name you want to give, and how many times that will be used. That is nothing but the surface, which is denoted by the S. For example, the ith entry in the surface index for cylinder, J is the value of the largest key on the J track on the ith surface. So the total number of surface is calculated with the help of multiplication of that cylinder with the surface. So S C multiply by S. So the method of maintaining a file and index is easily called as an ISAM, which stands for Index Sequential Access Method. This is the first one. Then second one type is hash index. Hash index is already discussed into the previous one unit, which is a hash table. So which is same as an hash table techniques. But there are again two techniques which is regarding with that hashing, which is rehashing, and second one is open addressing, and third one is chaining, which already discussed into the previous unit. Rehashing means what? If you assume some memory allocation for one database, but that is not sufficient for the database, then again we just use a rehashing technique for the renewation of that memory allocation. Then open addressing means what? Random f of I is equal to random function, which is directly the empty functions, means what? Whatever at the runtime we allocate a memory allocation. And the chaining means what? We just continue the previous one database to the second one, which is a alternative solution for the rehashing. If you want to do, if you do not want to the rehashing, means you memory allocation you want to continue to the next one, then you just use a chaining. If 100 MB data is used, then again you want to more a 51, then allocate the second one 50, and then continue that with the help of chaining with the previous 100. So this is called as a chaining. Then third one is tree indexes, which is nothing but also called as a B tree. Actually, B tree is a separate topic we will discuss into the next lecture. But shortly, we just understand exactly what is a B tree. So the basic idea is searching using any search tree, which is successively divided into the searching domain. Means which is a main data which is divided into the number of parts, which is called as an M weights. So this is nothing but the uh, B tree. So which starts from the M up to the M minus N. Then the next is trie indexing. In index structure, there is a particularly useful when the key value are varying size is a tries. Tries is a tree of degree which is M greater than equal to 2, and in which the branching at any level determined not by the entry key value but only by the portion of it, just divided into the two parts. So it having again two types. First one is branch node and another one is information node. So which will be checked with the help of example. So consider that example which is showing a structure of tree and which showing the number of words how we can store into the database. So start from the root node. So this is empty. This is a root node which is start with the three different nodes, which is first one thread B, second one is G, and the third one is dollar. Dollar is indicating the end. Dollar indicating the end. There is null value. There is no some information which is attached with the thread. So start with the B first of all. Then B is connected with I. So BI, again I having a two childs, G and L. G is the left one, L is right one, again which is depending on the alphabets, which is comes before, which is having a left hand side, which is comes after, which is having a right hand side. So again G, then again G having some another one thread, and one is with the help of dollar which is end. So which is end, which is check out first of all, which starts from B, then I, then G, means we continue the word big. Then it is end of that word which is showing with the symbol dollar, which is showing this and this symbol so dollar, and which is the end of that big. Then continue with the next one B I G. Then again it is connected with G, then E, then R. What is the spelling? Bigger. And then we add that dollar, means this is the end of that thread. Then check out with the B I. Then right hand side L, again connected with second one L, which is completed the word bill with the help of dollar symbol, which is showing that end of that thread. Then next one is B, then G, sorry, B is finished. So left hand side is finished. Then go for the right one. Right one is starts from G. Then G is connected with O. Then again O having two threads. Left one is also O, right one is S. Then check out for this left one, O connected with D. So complete that first of all from the root one to the left one. So G, then O, then again O, then D. Then dollar. Dollar means what? End. So again G double O D, which is making a good. Then check out the right one, which is G O, then S H. G O S H, ghost. Then dollar, which is showing that the end of that word. This is the last one topic, which is a tries, and which is showing the two types of node, which is a branch node and information node. I hope you understand betterly with this help of example.